しくお願いいたします。
Thank you, Chairman, and good afternoon, everyone. We'd like to explain our research on behalf of NIT Gunma College. Introduction. The most of waste material are initiated in Japan and generated toxic gases. On the other hand, the hydrogen is well known as a clean energy due to no emission of any toxic gases. However, the industrial hydrogen evolution system uses fossil fuel. Therefore, it does not hydrogen. Next, in this work, we investigated establishment of hydrogen evolution system using waste material such as lime descant and iron foil to provide pure hydrogen gas with no catalyst and no toxic gases. Furthermore, surprisingly, we found that this reaction is not proceeded theoretically. So we also investigated study of their reaction mechanism. It is known that aluminum can react in acid as well as a base due to an amphotic metal. According to the reference, the aluminum foil, the reaction is like this. On the other hand, the lime descant is containing the calcium oxide over 99%. So when dissolved in water, the CaO is to be a calcium hydroxide and strong base solution. To combining the aluminum and descant, the reaction is as follows. According to the MSTS of CaO, the solubility of CaO is 0.36 gram in 300 ml water. Thus, air can react with CaO about 0.35 gram. In this case, hydrogen is evolution until 475 ml in a cellulose on reaction stoichiometry. Next, experimental section. The descant and aluminum foil added water, and the reaction carried out hydrogen evolution system like this figure. Finally, the gas components are identified by gas chromatography. Next, next, result and discussion. This figure shows the result of reaction of aluminum foil with the descant in this reaction condition. To compare the descant, we also carried out CaO reagent as a From 5 minutes later, the gas was evolved and increased with the time. When used CaO reagent as a comparison and similar trend was obtained. Therefore, it is found that CaO contains the descant has an activity for the reaction with air foil. This figure shows the result of the components of every gases from reaction with air foil identified by gas chromatography. The hydrogen gas has gradually increased and reached to 99% at 180 milliliters. We found that the hydrogen gas was evolved from a reaction of aluminum foil with the descant. So hereafter, we explain the hydrogen evolved gas as hydrogen.
Next, we examined the dependence of the evolved hydrogen on the descant. This figure shows the dependence of pH value and the amount of evolved H2 on the amount of descant. White plot indicates the pH value. Red plot indicates the amount of evolved H2. Increasing the descant usage, evolved hydrogen is dramatically increased until 0.36 grams used to descant. However, after that, descant usage after 0.36 grams, evolved hydrogen is slightly increased, not proportionally increased. On the other hand, the dependence of the pH value were also similar result. So this result gives us an evidence the reaction is dependent on the solubility of the descant. Next, this figure shows the dependence of reaction rate and the final amount of evolved H2 on the amount of air foil. Red plot indicates the reaction rate. White plot indicates the final amount of evolved H2, which amount is end of the reaction. Increasing the air foil usage, the reaction rate and the final amount of evolved H2 were proportionally increased with increase of amount of air foil. we revealed that the reaction rate from airfoil was found to be 15 milliliters per minute per gram aluminum. Furthermore, in the series we explained before, aluminum reacts 0.36 grams of CaO. Hydrogen was evolved 475 milliliters at a maximum due to stoichiometry. However, surprisingly, we obtained hydrogen 922 milliliters. We considered that the reaction of airfoil with descant does not stop. Explain in detail. The chemical reaction proceeded as follows. Usually, airfoil reacted with CaO up to 2 equivalent against 1 equivalent of CaO. Therefore, even if we used more than 0.35 grams of airfoil against 0.35 grams of CaO, it does not react anymore. So the theoretical value of evolved hydrogen is 475 milliliters. However, in our result, amount of evolved H2 were 922 milliliters at 0.7 grams of airfoil. Then to compare the base solution, we examined NaOH. In this case, amount of evolved H2 were 446 milliliters at 0.7 grams. It's almost the same amount as theoretical value. Therefore, it is considered that reaction of airfoil with CaO are proceeded on the basis of other chemical reaction. Therefore, we investigated the study of their reaction mechanism as a second theme. In order to identify the reaction mechanism, we examined addition of airfoil until evolved H2 will be stopped. Experimental scheme is as follows. After distillation of airfoil, add 0.35 grams of airfoil to stop the evolved hydrogen. This figure shows the result. Horizontal axis shows the number of airfoil addition. Vertical axis shows the total amount of evolved hydrogen. As a result, hydrogen is continuously evolved, even though the airfoil is added more than 20 times.
Then, I'd like to explain the changes of pH values and reaction conditions in this reaction. This figure shows that the changes of pH values in number of airfoil additions. A vertical axis indicates the pH values. The horizontal axis indicates the number of airfoil additions. In this experiment, the pH value was decreased with increasing of number of airfoil additions. It is considered that aluminate ion, which is produced as byproduct, was drastically increased in this reaction. This figure shows that the changes of reaction conditions in before and after the 24 times reaction. Since the reaction proceeded consecutively, the water solvent was decreased, drastically consumed. And also, the reaction flask was mostly filled up by the solid byproduct. As a result, in until then, we revealed that the waste material reaction by using airfoil and lime desiccant is proceeded on evolved hydrogen consecutively, even if the excess amount of desiccant, the excess amount of airfoil was used compared to amount of desiccant. Therefore, we predicted this chemical reaction mechanism as follows. In this reaction, we predicted two types of reaction mechanisms. As the first one, the calcium aluminate precipitate, which is produced as byproduct, is involved with this reaction as a solid-based catalyst like this. As the second one, the dissolved calcium ions or calcium complex ions are involved with this reaction as catalyst like this. In order to know a factor reaction activity of the precipitate and dissolved ions, we carried out the filtration and reaction with airfoil in the filtrated precipitate and LT solution. After filtration, the filtrated precipitate and LT solution were separated each other and add a few amount of water and airfoil in each solution. As a result, the gas was not evolved in the case of the precipitate. But surprisingly, the gas evolution was confirmed in the case of the electric solution. Therefore, it is considered that calcium ions or calcium complex ions are involved with the excess reaction of alcohol. Conclusion of our research, we found that the waste material reaction combined with waste lime descent and alcohol could be used for the hydrogen evolution system. This reaction is depending on the solubility of the descent. That means solubility of CaO in water. The evolution rate of hydrogen is about 15 ml per minute per gram Al. The Al foil is reactive with the descent more than 20 times of reaction stoichiometry. The calcium ions or calcium complex ions are involved with the excess reaction of alcohol. This reaction stream is like this. In future work, in order to know the factor to excess reaction, we will perform this reaction by using alkyl metal ions and alkaline all metal ions. And also, we will perform this reaction by using real calcium aluminate or mixed solution of calcium ions and aluminum ions. Thank you for the Professor Sasamori in Nagoya City University through that research support system of grant contest. And Dr. Shibata, Ms. Kribara, thank you. This is our presentation. Thank you for listening.
ありがとうございました。それでは質疑応答へと移らせていただきます。ご質問のある方は挙手をお願いいたします。ご質問のある方いらっしゃいますでしょうか。はい、ではマイクをお持ちいたします。
どうもありがとうございました。ちょっと聞きそびれたのか読み飛ばしているのかどっちか分かんないんですけど、これアルミホイルの廃物利用というかいうことですよね。でこれ実験しているときにアルミホイルの使用量の依存性っていうのは調べてるんだけど、同じ重さ同じ質量のアルミホイルでも形状、例えばねくるくる丸めたとか細かく刻んだとか、あるいはなんか工夫したとか、なんかそういう形表面積の問題が関係するような気がするんですけど、その辺どのぐらい調べたんですか。
Thank you for a nice. Could I explain your question in English? Thank you for your question. We carry out the dependence of alcohol. When we carry out the dependence of alcohol, we cut alcohol and broke aluminum or broke in this experiment. The cutting alcohol is good to reaction, but alcohol or block is not good to react.
The block. It's originally the aluminum is a foil. Foil means it's a thin film, right? What's the meaning of the block? You say.
すいません。アルミニウムを切ったものと塊にして丸めたのを比べて実験をしたところ、切った方が反応が良かったので、今回はそちらの方を。
廃物利用して効果を上げようというんだから、やっぱりその依存性って大事だと思うので、それも系統的にやると面白いかもしれないと思いました。はい、ありがとうございます。
ありがとうございます。ではもう一つ、はい、お願いいたします。
Perhaps you are very much aware that the aluminum metal itself cannot survive in the air. 日本でいくか。アルミの金属というのはね、本当に金属であれば空気中で燃えるんですよ。で、アルミナムホイルあるいはアルミナム弁当っていうのは表面は酸化アルミなんで覆われてるから。だからそれを知っておいてもらいたいのが一つで、だけど水素が出るんだからアルミ金属がどっかにあるんでしょう。 でそこのところね、バランスがやっぱりちょっと必要なん計算するときにね。だから本当に全ての金属、鉄でもそうです。純粋な金属というのは空気中には存在しえないんです。表面は必ずやられてるんです。やられてるっていうのは酸化されたりとかね。で特にアルミホイルは薄いからさ、表面であるアルミナの量って結構多いんですよ。だからそれを効果っていうかね、その影響というのをまた検討していただければ、非常によくやられてると思います、研究は。さっきの先生の質問そこにあるんですよね。
ありがとうございます。それではお時間も参りましたので、以上とさせていただきたいと思います。群馬工業高等専門学校の皆さんでした。ありがとうございました。